Hey class, Mr. Mojan here with a little lesson to bite over the time while I'm away. So we have a question here that says, suppose f of x is equal to 3x squared and g of x is equal to cosine x. And you have two tasks, find f prime of x and dg dx. So it's not a trick question. All I'm asking you to do is to find the derivative using the power rule, most likely, and the derivative using one of our special trig situations. So f prime of x, if f of x is 3x squared, then f prime of x using the power rule would be 3 times 2x, better known as 6x. And likewise, g of x, if that's cosine of x, then the derivative with respect to x of g would be negative sine of x. Pretty straightforward. So that helps us to build into the next question, which you might have figured out based on the fact that we're talking about the product rule. Well, what's the derivative of those two functions' product? What's the derivative of y equals 3x squared times cosine of x? So a very common approach would be to write this. Y prime, let's say, is equal to, well, this part here would be 6x from above, and this part here would be negative sine of x from above. And if you simplify those, you get, let's see, negative 6x times sine of x, right? Well, hold on, I was supposed to pause. Let's see here, the last slide. The derivative of a product isn't the product of derivatives. So this rule is a pretty easy one to mistake, because for limits, things are as you'd expect. It's sort of common sense, but for derivatives, unfortunately, it is not. So this is a very, very common mistake. For the derivative of a product, which is to say the overall structure of this problem is one math thing times another math thing, we need to use a special rule. And that rule is called, as you might expect, the product rule. So this is something that's going to eventually go into your booklets if you want to go and write in there now, or in the notes for this video, either way, but eventually into your booklets. The derivative of f of x times g of x is f prime of x times g of x plus f of x times g prime of x. So a couple things to take away from this, just looking at the structure of this rule. We haven't proven it or anything, but it's a useful rule to know by heart. In fact, you kind of have to know it by heart to do calculus well. Is you essentially have the overall structure of the problem repeated, fg, fg. The first one gets the derivative in the first scenario, and the second one gets the derivative in the second instance, right? A more concise way to write this, sort of to get the gist of what's happening, the derivative of f times g, the way I usually write it, to reiterate the structure, is I just write the structure of the problem, which is f times g. I put the derivative on the first case, I put the derivative on the second case, and it's added together. So how does this actually work in practice? Well, let's take a look at the actual problem we attempted to do incorrectly up here, which was y equals 3x squared times cosine of x. So y equals 3x squared times cosine of x. What I would encourage you to do at this point is to have another little visual gimmick here. Oops. Come on, iOS 11. There we go. A little gimmick here. I have the Swedish Chef, for those who remember Sesame Street. The Swedish, or maybe it's Muppets. What's the difference? Swedish Chef here is a reminder to list out our ingredients. So essentially, this is a recipe, right? It's saying to take the derivative of these two parts, you have to have a certain mixture and a certain order of these two ingredients. So I'm going to call f, this first function, I'm going to label that as f, and I'm going to label this function here as g, okay? So just off to the side here, I'm going to label exactly what I have. F is 3x squared, and g is cosine of x. And I'm also going to need f prime and g prime, right? So f prime is going to be 6x, and g prime is going to be negative sine of x. So all four of my ingredients are essentially laid out here, right? A little trick some people like to use. I'm not a big fan of tricks, but if If you list it in this way, then your factors are basically going to be diagonal from each other. Whatever works for you. To know the rule, I like this f prime g plus fg prime sort of pattern. But in any case, you're going to place these four ingredients according to this pattern. So the first thing is f prime, which we just saw was 6x times g, which is just the original function cosine of x, plus, this time it's just plain old f, which is 3x squared. And now the second part gets the calculus here. It's going to be times g prime, which we saw was negative sine of x. So just to reiterate, listing my ingredients here and then putting them in the recipe, and that's all equal to dy dx. That's the derivative with respect to x of y. Oops. So simplifying slightly, I have 6x cosine of x. I bring this negative out front, negative 3x squared sine of x. And for most purposes, this is a perfectly satisfactory answer. That's the derivative of this original function way back up here. So that's the product rule there. We'll do some more examples on Wednesday, but in essence, if you know this pattern and if you can find the derivative individually, then you could put them into that recipe there. Second part of the video deals with the quotient rule, very similarly related. In fact, if you know the product rule, you don't really need the quotient rule. That's provided you learn something else in the future called the chain rule, but we'll get there when we get there. So let's take a look at our function this time. Find the derivative of 4x minus 4 over x squared minus 3. So it's a derivative of a quotient, right? It's one math thing divided by another math thing here. So how does that work exactly? Well, a naive person may say, well, okay, derivative of the top here, 4x minus 4, that's 4. Derivative of the bottom, x squared minus 3 is just 2x. Simplify, and I get 2 over x, right? Let's see. The derivative of a quotient is not the quotient of derivatives. So once again, this is a big old mistake. Very, very common. So we added a specialized rule here. It's the quotient rule, which I've already printed out here. It looks quite beastly, and it's tricky to remember, but I want to give you a couple of ways to remember it in terms of its pattern. First, notice that there's no calculus in the bottom here. There's no derivative, there's no prime, there's no dg dx. It's just the plain old bottom squared, right? So, just a little note here. No derivative in the denominator, right? It was g of x, now it's g of x squared. And notice that the numerator is basically the product rule, right? F prime g minus fg prime. The big difference there is, of course, this minus sign, right? And if you think about multiplication as repeated addition, then repeated subtraction kind of goes with the idea of division. So the minus sign is sort of a natural recurring feature of the idea of division, right? So again, the sort of simplified version that takes away some of the fluff is the derivative of one function divided by another. F divided by g is f prime g minus fg prime over g squared, right? And just like the last case, I like to write this out as just fg, first derivative, second derivative, minus over g squared. The pattern there just sort of helps emphasize what the procedure is, right? So let's take a look at this problem again, this time without the accompaniment of the goofy video. 4x, or the original function is y equals 4x minus 4 over x squared minus 3. So once again, we're going to list out our ingredients. So this is the function I'm calling f, and this is the function I'm calling g. The recipe here says I need 4 parts, f prime, g, f, and g prime. So I'm going to list everything out here. Plain old f is 4x minus 4. Plain old g is x squared minus 3. f prime using just mx plus b slope derivative is 4. G prime here is power rule 2x. So the quotient rule states that the derivative of a quotient is this right here, f prime g minus f g prime over g squared. Put everything in here based on our recipe, or on our prep table here rather. So y prime is equal to, let's see, on the bottom I have 2x, oops, take it back. On the bottom I have x squared minus 3 squared. Remember the bottom was originally x squared minus 3, and it's still there, it's simply raised to the second power. Again, why these things are true, we'll look at a bit more in the future, but for now, I'm mostly interested in your ability to understand, or rather to know what these rules say. We'll talk about the understanding when we have a bit more time. F prime here we have as 4 times just plain old g is x squared minus 3. Use parentheses to indicate that I'm multiplying them all together. Minus plain old f, which is 4x minus 4, times this time g prime, which is 2x. So f prime g minus f g prime all over g squared. Quite a bit of opportunity for simplification here. So let's see, if I distribute the 4, I get 4x squared minus 12. And keep in mind, I'm subtracting all this. What I'm going to do is I'm going to distribute the 2x and then make everything negative afterward. So I get 8x squared minus 8x all over x squared minus 3 squared. I could expand this, but it's actually not usually needed. That's something that you learn with practice. And let's see, on bottom we still have x squared minus 3 squared. Just doing our recipe here. And on top we have now 4x squared minus 12 minus 8x squared plus 8x. So distributing the negative to both. Simplifying finally, we have, let's see, term here, term there. So we have negative 4x squared, descending order, plus 8x minus 12 over x squared minus 3 squared. Now you could, if you wanted to, go further and factor out a negative 4 and all that, but notice it's not going to cancel on the bottom. Sometimes it is useful to simplify it, and sometimes, in this case, you can see that it won't really help you much. So this is a perfectly satisfying answer by using the quotient rule. And finally, I'll leave you a little challenge here. We'll eventually find this rule in class, but if you want to see if you can figure out what the derivative of tangent is, I've actually given you enough information both in this video and in the ones, or in the lessons that we've done with the other trig functions to figure this one out. So I'll leave you with that, the product rule and the quotient rule, and I'll see you in class.